Thank you very much. And thank you for asking questions. And let me present a new speaker. This is Christoph Dobrusskin, and the title of his presentation is Horological TRIZ Ruminations. Christoph, please, the floor is yours.
Yes, I'm fighting with the system here. Can you see me?
Not yet.
Okay. Well, maybe the camera doesn't work. Let's see if I get the share screen at least.
Most important that you could share the screen. It's a green button in the bottom usually.
Yeah.
Or in the middle.
Okay. I seem to have problems here with the.
Okay. So no, not yet. Wait a second.
Okay, so the camera will not work, and
but we don't. Well, sharing the screen doesn't work.
Sharing the screen also doesn't work.
Okay, but you sent me the presentation, right?
Yeah, if you can show it, that would be.
I will do it. Just
I'd be grateful.
And just a second, you just will tell me where I have to turn the pages.
Yeah.
Okay, now I'm sharing your, just a second, it must, first it is uploaded, yes. Yes, okay. Now I'm going to share it. Okay, share the screen, okay.
Great.
So do you see it, yes?
Yeah.
Okay.
I see it. So as you probably can gather, I'm more of a team player and Zoom is new for me.
All right, no worries. We solved the problem. You just tell me when to turn the slides.
Yeah, it's not in presentation mode.
No. Yeah, I will put it now. Just a second. Yes.
So, good afternoon, everyone, or whatever time it is where you live. I'm Christoph Dobrusskin, and I'll blame COVID that I prepared this talk. Maybe the next slide now. So I live and work in the Netherlands. I'm employed as function developer and patent coordinator at Philips in Eindhoven. And I've been using TRIZ for quite a few years. And I'm also teaching TRIZ both to engineers and school children. Next slide, please. So in this time of COVID, yeah, I got sort of bored, if you want, and I wanted to do something fun with TRIZ. And I have always noticed that many lists of examples of the 40 inventive principles, they exist in different fields of technology. But apart from the work of Altshuller, I haven't actually found structurally those lists referring to patents. And also I got interested in horology. I mean, probably all boys, maybe girls interested in technology, once they see these ticking mechanical timepieces, yeah, they get fascinated. And so putting these two together, I decided to make a list of patent examples of the 40 inventive principles in the field of horology. Next slide, please.
Oh, sorry.
And the reason why patent documents are really, really nice is basically is now the same as it was in the time of Altshuller. Patent documents contain, mostly at least, a pure description of an invention. They should be documents that tell you how to build something. And when you look at the modern patent documents, they also clearly state the problem that the inventor wanted to solve. and how that problem has been solved. And so taking that together, they are a very illustrative and clear example of how 40 inventive principles could be put to practice. Next slide. So I will not show you a catalog here. Apart from it being boring, it's not yet finished. It's sort of in final draft, and I need to find some time to continue and finish it. But all the 40 inventive principles are illustrated with one or more examples. And I think I included about 160 patent references. But I'm still fine-tuning, trying to find more convincing examples here and there. Next slide, please. So what I can tell you today, however, is that I made a number of observations which I wanted to share. And that's on the classification of patents, on the MPV of patents, something, well, it's timepieces, the mists of time, specificities of mechanical timepieces, and conclusions. Next slide. So looking at the classification of patents. So some inventions, they are quite easy to classify. You have the GB number there. It's mentioned, it's called improvement in the construction of watches. So from the title, you don't see that much. But in the problem description of the patent text, it says that the object of my invention is to construct or convert a watch to go from 1 day to 7 or 8 days, or for a longer period if required, with one winding up. So obviously the inventor thought that the watches wouldn't last long enough once they have been wound up. And his solution is then later explained. And he writes, I employed 2 mainsprings and barrels, or spring wheels, of suitable power in lieu of a single mainspring and barrel. So clearly, making 2 out of 1 principal segmentation, divide an object into independent parts has been used. And this is an example of a patent that is pretty straightforward to classify. Clearly goes from problem to solution, and you can name the inventive principle. Let's move on. Now, some others, they show a little bit more difficulty. This US patent, timepiece movement fitted with a vibrating alarm. In the title, I thought, wow, finally a good example of vibration. As, yeah, inventive principle, mechanical vibration and vibrating alarm, it's an obvious association. But when you then look into the problem statement of this patent, it says this watch has drawbacks. However, indeed, the alarm mechanism includes specific elements enabling the mechanism to operate in silent alarm mode, which increases the complexity and size of structure. So he's not solving something about mechanical vibration. He's solving a problem within mechanical vibration about complexity and size. Next slide. And then his solution, and we can only look at the green text here, basically says, at the end of his claim, he says, wherein the vibrating element of said vibrating alarm mechanism is said oscillating weight. So that's merging. He integrates the weight into something else. And so, yeah, I thought something for vibration, but I ended up very differently, at a very different place. So next slide, please. And then we have this patent. A US patent, actually a patent application still, device for adjusting the length of a bracelet. Now here, what you see in the image is the back of a clasp of a watch, and it's for a metal bracelet. Where you see the numbers 35 is one example of many little holes where the element number 1 can be moved. And moved to, and so it can move to the left and right, and thereby making the clasp bigger or smaller. Now, the question here would be, which principle was actually applied? Because, yeah, instead of having one hole, you have many. It could be segmentation. On the other hand, this element number 1 sits inside the clasp, so it's hidden from view. So couldn't it be also nested doll? When you wear a watch, you may know that in winter, when it's cold, your wrist gets smaller, and in summer it may grow a bit. So maybe it's cushioned in advance, because with a clasp like that, you take into account that the diameter of your wrist can change. Or is it partial or excessive action, because you know you have a fixed, semi-fixed width of your wrist, but yeah, you use with a clasp, you introduce like an action which could be adjusted later. So you have to really, for those aspects, you have to also, with some of the patents, be very clear, maybe look at the problem statement that the inventor wanted to tackle, and from there, then judge which principle would be best to use. Move on, please. Now, let's move on to the next point, which is on the MPV of patents. And what you see from left to right is a little bit the historic development of the main watch face. On the left hand, you have a watch or a clock with a single hand, just the hour hand. And that's how clocks started in the late Middle Ages. In the middle, you have hour and minute hands, and that was introduced later. And let's say 1800 or so, pocket watches, they all looked like that. If you don't wear an Apple Watch, but you still have something mechanical, then probably you have something like the picture on the right on your wrist at the moment. Shows hours, minutes, and second hands. Now, you would expect that today's patents would somehow stick with the most modern one, because it developed along these lines to increase the MPV. Next slide, please. But then you see, and I point to the picture on the right, the WO patent application. I think it's from the German Meistersinger company, and they patent something around a watch with just a single hour hand. Now, that sort of seems to move backwards. What's the advantage? What is the growth of the MPV if you assume that every new invention should be better than the old one? And on the middle drawing shows a so-called regulator watch, where the big hand is the minute hand, and the small extra dial on top is the hour hand. And those dials were used up until the end of the 20th century by watchmakers, because the minute hand wouldn't overlap with the hour hand that much. And therefore, when the watchmaker would adjust the watches he was repairing, he could almost always see exactly what the time is. And then you have a company, Resens, in the EP patent on the left, where they basically picked up that old-fashioned regulator style display and put it back into use. So what's happening here? Next slide, please. And I go further. So basically, I think the explanation is that especially mechanical watches, they don't, normal rules of utility do not apply. they have become luxury pieces or pieces for connoisseurs, and therefore they can go in any direction they want as long as they somehow can sell it to their customers. In the previous slide, maybe we can briefly go back. On the right-hand side, Meistersinger only sells watches with a single hand, in our hand. And their slogan is basically, we are already in our times so much driven and pressured by time that having a watch that is very exact, but it doesn't drive you with the seconds or the minutes, is simply a luxury and worthwhile having. Resins on the left-hand side, they actually modified the dials so that the regulator watch never overlaps. And in this respect, they also go for utility. You have to get used to this kind of watch, but it obviously sells quite well. And it's a very expensive item. Next one. And this one is, I think, Jacques Dross was someone like that. And they really built automaton watches like they were used from the past, from long ago. Next slide, please. And then you have also MPVs, which maybe have less to do with the luxury market, but they simply point to a different market altogether. This US patent application is a watch that, based on a set of data, calculates and displays the wearer's remaining life expectancy. So altogether a different kind of time display. And here I want to also mention, because I have never seen this watch anywhere, that there's a difference in the patent that is applied and in the success in the market of those particular inventions from the patents. Next slide. Then we have the mists of time, because there are wonderful examples of how in watchmaking the inventive principles have worked, but there's basically no patent about it. So inventors, before the existence of patent law, they are unknown. Who invented the watch face moving from just the hour hand to include the minutes? I couldn't find it. There are inventors from China, India, Arab countries. Like in the illustration, you see a Chinese water clock. Who invented those? And then there are inventors who patented early on. And those patents are basically in no databases, even though they exist as written documents. Next slide. And a good example is the patent of the tourbillon from Abraham Louis Breguet. The company still exists, and it was a fantastic experience to actually call them. I sent a mail and asked whether they had any information about those old patents, because they are not logged in the European database of patents. And I got basically within 2 hours, I had an answer with a suggestion that he could send me a facsimile of the original patent. They had once printed them and he had still a few lying around. So it's a very expensive, luxurious brand, but hell, they really look after their customers or people who are interested in. It was a perfect service. Next slide, please. Then there are the specificities of mechanical timepieces. So I really wanted to stay mainly mechanical, but there are also some rather specific or narrow inventive principles. And then you really have to be lucky to find those examples. For example, principle 38, strong oxidants. This patent is about how you treat with strong oxidants a mechanical balance spring to make a better oscillator. So if I hadn't found this one, this wouldn't have existed in this field. It's simply not used. or it may be used in the manufacturing process, but then there's a generic manufacturing process, and by chance they use it in watchmaking. Next slide, please. And then there's also principle mechanic substitution. Yeah, that's obvious for mechanical watches, is a difficult one. But what you see here is that they use satellites to adjust the time better, and maybe even have the watch give you a location. So yeah, those examples. Next slide, please. So we're coming to the conclusions. Number one is that to illustrate inventive principles, you have to be really precise and carefully identify both the problem as well as the solution that is suggested. For mechanical timepieces, nowadays, I think the MPV is not based on utility, but on other, probably status-related factors. Many fundamental inventions in mechanical watchmaking have been made a long time ago, and the inventors have simply been forgotten, or their documents are not freely available in public databases. And then some inventive principles are not easy to illustrate, as their proposed direction leads away from the core of the field to be investigated, mechanical timepieces. And then I have a last slide. And the final conclusion was that this exercise has been and still is a lot of fun. I didn't know that patents could be politically motivated, but I think if you look at this one, it really is. And with that, I like to thank you for your attention. Any questions?
Okay, thank you very much, Christoph. And I just need to, jump to question. I see the question from Jerzy. Isn't it is just dynamization? Jerzy, what exactly?
Oh, it's probably the clasp you're referring to.
Mm-hmm. Yes, precisely.
Yeah, maybe another one on the list.
Yeah, of course, often you can see a number of inventive principles together. So
yeah,
what a surprise. Second question from Horst. The wonderful one-hand watch reminds me of Leica Celian, of a high-end digital camera only capable of capturing monochrome pictures, or a digital camera body without a screen. Don't these examples show a shift from technical MPV to emotional MPV?
My answer would be yes and no, particularly the first. Both have actually, for Leica, both have functional advantages. The monochrome camera has a much higher resolution because they don't need 3-colored or 4-colored pixels on the chip. So they only have gray pixels, which increases utility, much higher resolution. And the second one, the digital camera without a screen, that prevents lots of people from, I think it's called chipping, looking at the screen, and but they should concentrate on taking the picture and look on the output later. So both actually here have utility. Generally, though, I agree with your statement. Emotional plays a big role.
And I must add that Christoph makes wonderful black and white pictures, especially at TRIZ conferences. Christoph once shared with me a collection of set of his pictures he made, I think in Italy. We were at a conference. Yeah. They were brilliant, excellent.
Well, we can, hopefully we repeat that experience some other time and can see each other in person.
I'm really waiting for it.
Oleg, I did consider electronic clocks, but yeah, I think you can almost make a separate chapter on that, because it went from mechanical to electronic, then came quartz, and now you have with particularly the Apple Watch, you have like smart watches. It's really moving in an that is moving into an entirely different direction. And I really wanted to focus on a more closely scoped field.
I see. Thank you, Chris.
Also, yes, I see also a question from Srinath. There are actually, if you look at the S-curves and basically the trends also, there are some very interesting other conclusions that should be drawn here as well. Obviously, time doesn't allow.
And Christoph, my question would be, are you going to write a book about it?
If I have time, who knows? But
Yeah.
it's, I think I will probably publish the 40 principles in one way or another. Whether it will be a book, I don't know.
That would be fantastic. Okay. All right.
Thanks all for the interesting questions.
Thank you very much, Christoph. Thanks everyone who asked questions. Thank you.